So the question that we're supposed to address in this section is here, and Michael played the philosophy card. You're just a philosopher, and therefore useless. Now, the last 8 or 9 meetings that I've been to have been in places like the Los Alamos National Lab or the Association of American Mechanical Engineers or Dayton, Ohio Wright-Patterson Air Force Base. I hardly talk to philosophers. The question of security blanket was actually resolved almost within months of my beginning to do applied ontology in the present sense, when I came into contact with a Flemish medical informatics scientist by the name of Werner Koester, some of you will know him, who had a team of people who were building a new an ontology-based medical record system. He had 40 people working for him. He had a company called Language and Computing, and basically what they were doing was trying to produce a multilingual ontology-based medical record structure to enable translation between different European languages of medical text. He had built into his system for entering data into this structure a number of rules, and one of the rules was always distinguish between continuant and the current meanings of terms like poisoning, which can either mean the process of poisoning somebody or they can mean the result of poisoning somebody. And when he added this rule, he was measuring the speed and the number of errors his data enterers were committing. The reliability was increased by something like 20%, and the speed was increased by 40%, because they were given flags. If a word like poisoning arose, they always had to choose whether it was the continuant meaning or the occurrent meaning. So this is a practical benefit of making just this kind of distinction. The question, why do we need upper ontologies, is actually 2 questions. Why do we need top-level ontologies, by which I mean absolute top, nothing above them? And why do we need mid-level ontologies, which I take it is what we've been talking about here? I'm only going to be talking about top-level ontologies, at least with these slides. And of course, that is a silly question. There are bad top-level ontologies. We don't need those. We only need the good ones. The real question is, why do we need a good top-level ontology? And this question almost answers itself. How do we pick out the good ones? Well, we find out which work, which actually help people, which give rise to benefits in the real world. So this has nothing to do with philosophy. It has everything to do with real-world practice. A good top-level ontology is a top-level ontology which is used in many real-world efforts, which gradually grows and improves and benefits from the testing which those real-world efforts subject it to. And it also tells us what the answer to the question is, what is a TLO good for? Well, it's good for doing all of those things which are bringing benefits in real-world applications of top-level ontologies. I'm going to give you 2 examples which I think should make this point clear. Why go all the way up, is the question. Why not just develop local ontologies to meet your needs? The Human Genome Project was completed, and so was the mouse and the fly and the rat and the yeast genome project. And biologists were then wanting to use the data thereby released to do experiments on model organisms and draw conclusions from those experiments for human organisms. There are lots of things that you can do with mice that you can't do with humans. And so you can do many, many more experiments with mice and then try to draw inferences from the results of those experiments for how to cure diabetes, for instance. You make a diabetic mouse, you throw all sorts of chemicals at the mouse, and the ones that help are then the ones that you start exploring for human purposes. And the first problem that they encountered when they started to work on the genome data across organisms was that every organism community has its own vocabulary. They have their own data structures, their own ways of dividing up phenotypes and so on, but in short, they have their own vocabulary. An example would be, you want to study. Now, of course, one approach is, well, all the human biologists get together with all the mouse biologists and make mappings between the 2 languages. Or all the human biologists get together with all the yeast biologists and make mappings between the 2 languages. But that is not future-proof, because none of the mappings are going to be extendable to other organisms. So what you do, you move up a level, which is exactly what the Gene Ontology did. They created a model organism species-neutral vocabulary for describing gene products. And gradually it became formulated as an ontology. They called it an ontology when it was still a vocabulary, but it now is an ontology. This is future-proof because it fits whatever organisms come along. And now that is the lesson that we learn. The way to solve problems of data integration is not pairwise mappings between different communities. Rather, it's moving up to a new level and embracing all the communities in an ironic fashion in such a way as to be future-proof, because what works for these 17 communities will work also for the 18th community. That created another problem for the model organism research community. They had the Go. The Go was a fantastic resource. It enabled all kinds of discoveries, new ways of using biological data that no one had foreseen. But there are no diseases in the Go. There are no anatomical terms in the Go. There are many kinds of terms not in the Go, which they were needing to use in their research. And so when they tried to use terms from these other disciplines, they found that there were all kinds of mismatches. The way biological processes are described in the Go is different from the way that they're described in the influenza community. So again, the solution is to move up. You move up one level and create a vocabulary for talking about all the phenomena of interest to the life sciences that is domain neutral. And that's what they did. It's called BFO. And then BFO began to be used also by other communities. And again, just as the gene ontology was future-proof to the introduction of new organisms into the research warehouse, so the BFO is future-proof independently of the introduction of which disciplines you introduce into the data warehouse. And of course, the BFO changes in light of the needs of the new disciplines which come forward and need to use it. And that's the answer to the question, where do we draw the line between the two? This is the way BFO works, or worked in the case of gene ontology. It provided the architecture which enabled all of these ontologies to be developed in tandem with each other, all using the same terms, all provided with definitions, and the whole thing worked very well. It created, there are now, 64 ontologies in the OBO library, which are BFO conformant. All of the ontologies in the OBO Foundry are BFO conformant, and then there are something like 240 other ontologies outside the OBO world, which are also BFO conformant. Now, what do you get? First of all, you can have a safe division of labor. You can develop the protein ontology while he develops the RNA ontology, and you know that your two ontologies will fit at least to some degree because of the fact that they both use BFO as their starting point for writing definitions. You get a safer distribution of labor. You can leave people to develop things distributedly and again have some reassurance that they will come up with what is compatible. And then finally, you have an audit trail to reality. The BFO forces you to write definitions in such a way that you always, in the end, can resolve the definitions at points where you reach classes which have instances in reality which are being observed or measured in experiments. And then you can always check whether the assertion made with a given term is true, or at least is not falsified by experimental data by tracking through the logic of the definitions. In the olden days, before the OBO Foundry, chemistry ontologies were developed which would regard oxide and aluminium oxide as just as two instances. Now, this is a very trivial move, but now they wouldn't do that. They would say that they're classes, and then they can explain why aluminium oxide is a subclass of oxide. They can't do that if they only treat both of them as instances. And then another example, a mistake made by the NeuronDB database. They wanted to have a database of all proteins, but they cataloged the proteins according to function. So inhibitor, dopamine receptor, and so on. They just had one classification. But then they needed to link their data to protein data. And they couldn't do it because proteins were not mentioned, even though the column header above this long list was the word protein. And that's because they confused protein with function of protein, and BFO would have said from the very beginning, you need two ontologies. You need one ontology for the objects, which are your proteins, and another ontology for the functions. And then you can link automatically not just to the protein ontology, but also to the gene ontology, function ontology.
So Barry, one question that popped up yesterday was, I think Michael Uschold was talking about how relative, in the sense upper becomes very relative. And so there's this, like you're talking about the very top level.
Yep.
And you talked about it in a almost evolutionary sort of way, right? That as things develop, it percolates up and you get that top. But that means essentially that the top level is defined now kind of in the context of all other policies that have been designed. As opposed, it's sort of almost quasi-empirical.
Yeah, absolutely. It's not.
Ontology, it's upper because of the following.
It's not quasi-empirical. It's empirical. So BFO has developed. It's changed very slightly twice in its history, precisely because of empirically identified gaps in what BFO needed to represent. There will be other additions to BFO sooner or later.
In which way? Would it extend it?
Sideways. So I'll give you an example of a gap that we are wanting to fill, but we still have not worked out how to do it in a way that's coherent with the other parts of BFO. But there are already physicists using BFO, but not very many. It's not a strong community. But as soon as we get a serious number of people in physics, particularly astrophysics, then we're going to have to do justice to the fact that space regions and time regions exist only relative to a frame of reference. So we're going to need to add to BFO some machinery for dealing with frames of reference.
But would that change the content, if you will? So, in a way, to still change the scope of the top level, or will it merely be sort of fleshing out the mid-level?
So
these very domain specific.
It's because we don't have an answer to that question that we haven't made the leap yet. But just to explain how far we have got, one simple view would be to say that the frame of reference is an information artifact, and say that spatial regions have a certain dependence relation upon a certain information artifact. Now, there are many things wrong with that. First of all, spatial regions presumably existed before the very possibility of information artifacts arose on this planet. There might be a path along those lines that would work, but it wouldn't satisfy us because it would involve a false belief, namely that spatial regions are dependent on there being people with frames of reference.
You might have a more disruptive change to make, because there is also the view that space is an emergent entity in physics. In that case, then cuts them off.
We have many customers already who are using BFO, and they're very satisfied. If we make a radical change because one day somebody in physics might want to take an emergent view of space, we would lose all our customers.
But isn't this affecting the real core of BFO or any other ontology? Because they are built with an ideal space, usually, which is not that flexible. And this is kind of what they claim is the fragility of our ontology.
Yeah, I still think you're making the same mistake. So Wittgenstein, I don't like to talk about Wittgenstein, but I want to talk about Wittgenstein with you because you remind me of him. Wittgenstein used to try and call into question our simple assumptions about things like value. I mean, monetary, cash value. And so he would have thought experiments. Well, there might be a culture behind some distant mountain where they sell carpets, not according to the area of the carpet, according to the height of the pile. And therefore, our notion of value is really much more flexible. But of course, there is no such culture behind a distant mountain. It's just a story made up to cause trouble.
But culture evolves, right? So you want to construct.
I don't. So, all right, when you find that culture, let me know and we can talk again.
You're not a philosopher anymore.
Thank you.
The question I have is, well, first an observation. I completely agree that when you have multiple different people describing similar things, you have to go up a level, whatever that means. I think we all agree that's a fuzzy notion, but you have to go up a level far enough so that you can capture the shared concepts. Okay, so you do that. That's great. However, you have introduced the concept of top level, higher as you go. And what you said, all about everything you said about moving up a level, has nothing whatever to do with there being one level above it. You can do everything you said, and there could still be 16 levels higher. So
You're doing the distant culture behind a mountain gambit again.
Can you give me any argument that says you've gone as high as you can go?
I'm an empiricist, so I can't prove a negative. Somebody may come along with an even higher level ontology. I haven't seen it, I'm not going to worry about it until somebody brings it to me.
Why would you call it a top level?
Because same reason that physicists call things what they call them, even though they're empiricists. If we think we've found the exact catalogue of quarks, then we say this is how many quarks there are. And if somebody then comes along and says, oh no, there are 3 more, then you change. Similarly, if somebody comes, you want me to call it a maybe top level.
How did the idea even enter your mind that it is the top level? Why would that idea even enter your mind?
That sounds like you want some autobiography.
I tend to dispute, but I might really agree with you if I understood where you're coming from.
BFO was created in close interaction with a number of very clever biologists who were working with a completely new kind of data, and who wanted to use that data for a whole series of different purposes. Over the years, it included practically all of the life sciences. The idea was to find a practically useful framework for charting out what ontologies needed to be built in order to cover all this data. Because they were just creating ontologies one-off, and they were not specifying very carefully, for instance, why the gene ontology needs both molecular function and biological process. As it happens, function and process are categorially different, but they didn't know about categorical difference. So I worked out, with their help, this framework. And immediately they saw that this would be useful. It's not a perfect, I haven't seen anybody show me a discipline, a scientific discipline, which wouldn't fit. And until I do, I'm sure as you can be in an empirical activity that this is the top.
One issue is better to have something that you can then show wrong than nothing at all. And generally what we've been dealing with in the past, at least when I came into the field, was nothing at all. So the way that this is, the way I tend to look at this is put some strong rules in, lay some stakes down, do experiments, and let's have people build ontologies when they can. But where we have demands, then fix it, right? We're not saying, right, there isn't a commitment that the BFO as it exists now is complete and completely correct. We accept fallibilism, we might, have to fix it.
Now the point would be, are they going to converge, or are we going to have still several ontologies moving on representing different scientific knowledge by different ways?
I and Nicola both agree that it would be very good if Doctor and BFO would know.
Yeah, but these are just 2. There are several.
Life is short.
Just as an initial thought, whether another way of carving out the world is everything is matter, energy, or information.
Are you a member of the Ontolog Forum?
Yeah.
So every 3 days or so, some new person joins and he says, I have a way of doing ontology. So we divide the world into energy, matter, and leprechauns. And then we can solve all the problems, and people even respond to these people. My view is, if you want to develop an alternative top-level ontology, fire away. Try and find people who will use it. I am confident, having worked this through with so many people in so many different disciplines, that we can capture the kinds of things you want to capture in what you just said. We've done a lot of work to extend it to meet genuine need. People may have better ideas, but part of this work is not philosophy or abstract theory. It's trying to help people. And if your matter-energy leprechaun theory can provably help people, and help people more than this, I will embrace your matter-energy leprechaun theory. So one of the core reasons for the existence of BFO was the gene ontology and the need to engineer a top-level ontology which would fit above the gene ontology. The other core influence was geospatial informatics. My very first ontological efforts in the applied world were done with geographers involved.
It seems to me that the success of the gene ontology shows that doing scientific ontologies is in a sense easier than approaching other domains like enterprise, business, and so on and so forth. It seems because you said that several times we created a vocabulary, and it seems to me that perhaps this is easier than dealing with a vocabulary which is already being used by people, in the common
sense.
In the common sense, so everybody, I know what a person means, I know what is an address, and so on and so forth. So it seems that some of the problems we discussed half an hour ago about this semantic web stuff, in a sense, do not appear or appear in a less relevant way when you are facing a scientific domain like gene ontology or whatever. So, and also it seems that the presuppositions somebody has when doing ontology for science are pretty different than those which people need to have when developing an ontology for, let's say, the social.
There was one thing I wanted to say to Mike's question, which bears on what you just said. To make it work, it's not good enough just to show it to some scientists and say, look, do this. You have to catch the scientists at just the point when they're ripe for that kind of thing. You have to grapple with them, wrestle with them for years on end, teaching them why this is good. And you have to learn from them, and you have to modify as you go along so that you do meet your needs. So it's hard work. To make an ontology work, you need to catch the scientists when they are exactly right for listening. And I was very lucky, amazingly lucky, because I became friendly with the leaders of the Gene Ontology at just the time when they were looking for some kind of logical structure so that they could really be an ontology rather than just a vocabulary. Now, and then I could grapple with them. I could get them to change their habits. It doesn't always work. They're still making mistakes even today. But still, ideally, I should be able to do the same thing with the US Supreme Court. So I catch them just when they are working out how to structure the law. And I say, look, you need to satisfy these principles, and then you'll have better data flowing through the legal system. But you can't do that with established social institutions. So one of the slogans which philosophers of science like to repeat, the philosopher should never try and interfere with the important business of the scientist. Philosophers should just look down and speculate. And I think that philosophers need aggressively to interfere with the business of the sciences where scientists are making mistakes. In the case of gene ontology, I can demonstrate that they were making mistakes. I could go on and on about errors that they were making, which a first-year undergraduate philosopher would be taught not to make. I'm not a philosopher of science either. I'm somebody who believes that the ontological approach can help people, particularly when it comes to introducing computers, to do better science. And that doesn't work in the social realm. And that doesn't mean that I'm not experimenting with people where it might work. So the military is really interesting, because there you can give orders. You can really change things. And so I'm making a certain small amount of progress.
A good example that we've been exploring is the realm of data, financial data, customer counterparty data. It's a recurring problem in any organisation how to manage and maintain information about individual entities, and that information is always muddled in with products because they don't have the philosophical distinction of customers a relative thing and a person's an independent thing. So that small piece of philosophy is put right back down to data and fix it.
Excellent. We now have a first-order logic formalization, which we didn't have recently. We have a very well-crafted and well-managed OWL formulation, and therefore also RDF and all the other things which come more or less for free. We have very good documentation for human beings. So I think we have the basis of what we need. We also have a lot of trained people who are used to using BFO, a lot of trained, very clever people. And that brings benefits. They write code and they teach their students. And so this means that if you need to hire somebody for an ontology project, then if you're already using both BFO, it becomes a little bit easier to find people to.
So Mike's point earlier, about how do you know if it's the upper level? I mean, I think this is a discussion that we've had about can you define an upper ontology intrinsically by just looking at its specification, perhaps its content, or is it defined relative to how it's being used? And I think you were arguing, or you have been arguing in the past that it is always defined relative.
Good.
Okay. So I think, Mike,
No, actually, I can give, if you press me, I can give you an absolute criterion.
Well, no, because then that would contradict what you said earlier to Mike.
That's fine. We can work that out when I give you I'll give you the absolute criterion. We'll see if it contradicts what I said earlier. We're assuming that upper level ontologies that are any good are going to define all their terms in some sense. The problem with candidate top level ontologies is that many of their terms are going to be so basic that there's nothing more basic in terms of which you can define them. You can elucidate them with paraphrases, but you can't define them in this non-circular way. So I would say that it's an essential characteristic of a top-level ontology that structuring terms, continuing, current, and so forth, are so basic you can't define them in terms of other things. That's not true of fruit and banana. Those can be defined in terms of objects. So a top-level ontology is top because it can never be used as a part of the process of defining terms which are even higher up, because the terms in the top-level ontologies, several of them anyway, are more or less forced to be primitive. One big difference between lexical or dictionary definitions and ontology definitions is that dictionary definitions are very often circular at 2 or 3 removes. And it's an important feature of a good candidate ontology at any level that its definition should form a set without circularity. Now, the view I hold about what an ontology is, it's a collection of terms and relational expressions together with axioms and definitions represented in a computer interpretable language, brackets, like, OWL, comma, common logic, close bracket. And that means that the vocabulary is an essential part, but the computer interpretable representation is also an essential part.
There are things that you can look at with the ontological eye and say, that's not really correct. And yet, with the pragmatic eye and talking to them on the enterprise, I can never convince them that it should be different. And I don't need to convince them that it should be different, because the fact is, we don't need to introduce an extra layer just to be philosophically correct. But I'm pleased to hear that in that case it wasn't.
So I would say that there are still huge possibilities for improvement of the Gene ontology even now, but it works much better than it did. It has huge numbers of people who use it. It's become indispensable for all kinds of research. So I think every system is a material object, which a lot of people don't like. That means that when you talk about IBM's system for making money, you're not really talking about a system at all. When you talk about the solar system or the hydraulic system of a car or the cardiovascular system of a human being, then you are talking about a system. That's the line out. The Internet of Things is primarily a matter of systems. It's a system of systems problem. It's still a material entity. But the material entity is full of pieces of material which have very, very rich capacities, functions, dispositions. I am, when it comes to developing new modules at lower levels, actually quite relaxed. I don't want to draw too many lines, but my intuition would tell me that a lot of what we need in order to develop a good ontology of the Internet of Things is already present in one or other of the ontologies that we already have. The information artifact ontology, for instance, the ontology such as we have it of biological systems, the ontology such as we have it of biological processes in artificial environments such as experimental labs. We have a lot of work which can be reused for an ontology for the Internet of Things. And I wouldn't have any objection to creating an ontology, the Internet of Things ontology. And the trick, and remember the audit trail at the end, the last slide. The trick is, if you build an ontology like that, you reuse as far as possible terms which have already been defined in reference ontologies, so that you don't need to redo all the work which has already been done by other people. So one easy way of making Dolce and BFO merge would be BFO gets all the real stuff, and Dolce gets all the fiction, myth, thoughts in people's minds, and stuff. So that would, we can have a clean division. So we could call it the Buffo Dolce super top ontology. And the two root nodes, one root node with the entity and the other root node with the Guarino entity.
Okay. Maybe Nicola might have to do first.